Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks. Hello and welcome. This is Michael Annis, and you're listening to episode 139 of the Space Rocket History Podcast. And now, Soyuz 1, Preparation. Recapping from episode 138, the third unmanned Soyuz test flight ended in failure. Kosmos 140 had to return from Earth orbit early, and it landed way off course, and it sank in the Aral Sea because a hole burned in the bottom of the descent module during its trip through the atmosphere. The burn-through occurred because the heat shield had been damaged during the installation of a temporary cap. If a pilot would have been on board, it is likely he would not have survived. The State Commission formed a working group to investigate all the troubles that occurred with regard to the control system. OKB-1 was once again disgraced. Also, keep in mind there were two Soviet moon projects going on. First, the L-1 project, which would send a Soviet crew around the moon before the U.S. using a stripped-down Soyuz spacecraft, the 7K L-1, launched by Chalomy's UR-500K Proton rocket. The other was the L-3, with the goal of beating the Apollo program by landing a man on the lunar surface. In response to previous failures of the 7K OK, the Communist Party Central Committee and Council ministers issued a resolution noting the unsatisfactory state of operations for the fulfillment of their August 1964 resolution to launch a circumlunar flight of a piloted spacecraft to the moon. Furthermore, the party issued a new resolution setting a deadline for the first piloted circumlunar flight to between June and July 1967, and the first lunar expedition by September 1968. Before June 1967, 4 unpiloted versions of the lunar spacecraft 7K L-1 were supposed to be launched. On March 10th, OKB-1 managed to fully equip, prepare, and launch toward the direction of the moon the first simplified 7K L-1 series, production model number 2P. The Soviet news agency TASS announced the launch of the latest Cosmos vehicle and called it Cosmos 146. The flight program of Cosmos 146 did not call for a lunar flyby and return to Earth at re-entry velocity. Instead, its mission was to test acceleration to lunar re-entry velocity using Chalomy's UR-500K launch vehicle and OKB-1's Block D upper stage. The experiment was a success. Cosmos 146 reached Earth's escape velocity, or as the Soviets called it, second cosmic velocity. So out of the 5 launches, the UR-500K now had 4 successful ones. During the flight, there were 2 firings of the Block D liquid rocket engine, once to reach orbit and a second time to prove that it was capable of sending the spacecraft to the moon. This was the first unmanned test flight of a circumlunar vehicle. Now back to the Soyuz 7K OK. Later in March of 1967, with the success of Cosmos 146, and in spite of the failures of the first 3 7K OKs, it was now time to plan for a Soyuz manned mission. The plan involved the launch and docking of 2 piloted Soyuzes. Soyuz 7K OK production model number 4 was assigned the role of the active vehicle. The active vehicle was supposed to carry 1 cosmonaut into orbit. 24 hours later, model number 5, the passive vehicle, would carry 3 cosmonauts into Earth orbit. After rendezvousing, 2 cosmonauts from vehicle number 5 would transfer through open space to vehicle number 4. The process involved a double airlock operation that had never been tested, involving egress from the passive vehicle and entry into the active vehicle. This was intended to be a rehearsal for the lunar program. That program called for the transfer of 1 cosmonaut from the lunar orbital craft to the lunar landing craft, and then, after walking on the moon, liftoff and docking in lunar orbit. The cosmonaut would return to the lunar orbital craft also by spacewalk transfer. It might seem strange that the Soviets planned the transfers of the cosmonauts via open space, but this was a necessity due to the risk of having an overweight design and the existence of rigid deadlines precluded developing a docking assembly with a hatch for internal transfer. They just didn't have the time. In fact, it would be 1970 before a docking assembly would be developed. In preparation for the new rendezvous mission, the Soviets made their ground testing procedures at the control and testing station and the engineering facility more rigorous. Additionally, they required that the subcontractors provide detailed conclusions with 3 signatures: the chief designer, the factory director, and the military representative, all affirming that the delivered items were in compliance with regulation for 3KA vehicles. The descent control system specialist modified the circuitry of the programmer, which had switched Soyuz test vehicle number 3 out of the flat guided descent mode into a steep ballistic one and driven it into the RLC. In the quest to raise the numerical reliability indicators, the developers of the electric circuits and instruments provided backup for elements and circuits. The numbers really did improve, but during testing, they failed to find many false connections and to prove that each of the parallel lines was in good working order. The hard-fought campaign to achieve reliability spread to the instrument building in Ufa and then to Kiev Pribor and other factories. OKB-1 personnel worked with factory specialists to develop ways to make the instrument testing procedure more rigorous. At the Air Force's experimental airfield near Feodosia, the Soviets continued to accumulate statistics proving the reliability of the parachute system. Mock-ups of the descent module were dropped from airplanes. The primary parachute system and backup parachute system were tested in many dozens of these drops from an airplane. The Soviet physicist and rocket engineer Boris Rauschenbach had his people set up experiments with the 45K star tracker, trying to understand why stellar orientation and spinning on the sun had failed in the previous unmanned missions. the idea of orientation using an infrared vertical came up. Technical assessments were quickly approved, and the Geophysica factory began manufacturing the instrument, which essentially was an analog of those that were already tried and true on Zenits and Molinas. On March 25, 1967, at the Kremlin, Smirnov, the head of the Military-Industrial Commission, held a meeting to examine the progress being made in preparation for the piloted Soyuz launches. According to the program that Mission had laid out in his report, the active vehicle would be launched on April 21st or 22nd, and the passive vehicle the next day. The active vehicle would carry one cosmonaut, and the passive one would carry 3 cosmonauts. After a successful rendezvous, 2 cosmonauts were to execute a transfer through open space from the passive to the active vehicle. A day later, after docking, both vehicles would return to Earth. Next, Karas reported on the readiness of the command and measurement complex. Kutasin reported on the readiness of the search and rescue facilities, and Kerimov, summing things up as chairman of the State Commission, confirmed that operations were going according to schedule, and there were no doubts as to the reliability of the vehicles. The head of the cosmonaut training, General Kamanin, introduced the Soyuz crews, 12 men in all. The primary crews included Komarov for the active vehicle, and Bykovsky, Krunov, and Yelizhev for the passive vehicle. Kamanin also announced that Yuri Gagarin would be Komarov's backup, which was a total surprise to everyone. Gagarin was considered a national treasure and was supposed to be grounded from all space flights. Both Smirnov and Mission immediately objected to the use of Gagarin, but General Kamanin told them that Gagarin should not be deprived of the opportunity for space flights. Smirnov said that assigning crews was the business of the Ministry of Defense and the State Commission, and the Gagarin issue would be decided not by him, but by the Politburo. Clearly, the Gagarin issue would not be resolved at this meeting. To conclude the meeting, Usarov and Ostashev were charged with preparing the Soyuz at Site number 31. According to their previous reports, aside from minor glitches they dealt with on the spot, everything proceeded normally. Tregrub, Aganzanov, and Chertok were tasked with verifying the readiness of personnel, documentation, and the work of all the ground surfaces, so that from the very start control could be conducted from the Yevpatorio Mission Control Tracking Center. And this concluded the meeting. Now, as if to complicate matters, the second experimental launch of the 7KL-1 had to be wedged into this schedule. This time, the plan called for it to fly around the moon in order to train the ground crew in how to control the return program. Chief Designer Mission flew out to the firing range on April 6th to participate in the launch, having first sent Tregrub and Chertok to Yevpatoria. On April 8th, under clear blue skies at 1200 hours Moscow time, the Soviets successfully launched the UR-500K booster rocket and the simplified 7KL-1 vehicle number 3. The spacecraft entered into an intermediate orbit and was given the name Kosmos 154. All 3 stages of the rocket and the Block D upper stage worked well. 40 minutes later, the members of the State Commission and the chief designers met in Launch Team Leader Kirilov's office. Everyone congratulated Shalomi with the success, but placing the ship into orbit was only the first step. In a day's time, the Block D had to be fired again to send the ship to the moon. So it was too early for Mission, who was responsible for the Block D, to declare success. 24 hours later, it was time to send the signal to fire OKB-1's Block D booster, which was supposed to take the craft out of Earth orbit and send it to the moon. This would be the second firing of the Block D. From Mission Control in Yevpatoria, the command was given to fire the Block D, but the second firing failed. This was due to a control system failure that resulted in the premature jettisoning of the ullage motors, so the main propulsion system of the Block D could not ignite. And the guilty party were the people who had been tasked with changing the circuitry of the instrument's automatic equipment, which controlled the second firing. Someone was to blame for failing to do this, but that information did not stop Chief Designer Mission from getting mercilessly berated by the chairman of the State Commission, Tyulen, over the high-frequency telephone line from the firing range. OKB-1's supply of simplified 7K-L1 vehicles was now used up. Future launches would require that they use the flight-ready L1 spacecrafts fitted out with all the systems. At least now, all resources could be dedicated to the Soyuz 1 and 2 rendezvous and crew transfer flight. And that is exactly what happened. On the evening of April 14, 1967, in a packed hall at Launch Site Number 2, Kieramov chaired a meeting of the State Commission during which the test results for 7K OK vehicles Soyuz 1 and 2 were presented, and the decision was made to fill the engine units with propellant and the attitude control and docking engine systems with propulsion fluid. Urostov and Astashev had supervised the testing and preparation of the vehicles at the engineering facility. In the State Commission meeting, Urostov gave his report providing a detailed account of all the test cycles of both vehicles. Launch Team Leader Colonel Antonelli Kirilov gave a report as a co-presenter. He took the liberty of saying that hundreds of glitches that occurred during testing were an indication that the vehicles were still green. This, of course, enraged OKB-1's chief designer, Vasily Mishin, and he sharply upbraided Kirilov. After the meeting, the insulted Kirilov turned to Chertok and said, "Would you explain to your boss, if he doesn't understand this, that I am not a little boy and shouldn't have to listen to such rantings? I'm just as interested in success as he. If something goes wrong, as an academician, there's nothing they can do to him. But for me, in the best case scenario, I'll be charged with professional incompetence." Alas, it would seem that neither a tactless academician nor a very experienced tester, nor dozens of other specialists who had gone through fire, water, and brass trumpets could foresee what was to happen 10 days later. On April 15th, Rauschenbach and Chertok were studying Nikolai Kamanin's claims regarding the cosmonaut training program when a conflict arose about the fact that only 4 hours were set aside in the training schedule for the crews to train inside the vehicles. Chertok agreed that Rauschenbach would administer additional lessons with an assortment of all possible situations that might occur during the process of approach, manual orientation, and manual solar inertia spin mode, paying particular attention to the constant monitoring of the consumption of propulsion fluid in the attitude control system. Later that day, a meeting was held with the cosmonauts, which caused more controversy. Gagarin and Komarov requested that automatic approach up to 200 meters be approved in the flight plan and that final approach be performed manually. But the previous approved flight plan did not call for manual final approach. In view of the disagreements, Mission decided to bring this matter before the Council of Chief Designers. Actually, rather than a meeting of the Council of Chiefs, a wide-ranging meeting took place, attended by all the members of the State Commission, cosmonauts, cosmonaut training center instructors, and firing range testers. The automation specialist who spoke first argued that rendezvous and final approach must be fully automatic, but Konstantin Feoktistok supported the cosmonauts' proposal. Chertok advocated a compromise version, under the condition that in the automatic mode, the spacecraft would go up to the final approach zone, which was 200 meters. If the main operations control group had no objections based on the results of a preliminary analysis of the system's in-flight operation, the cosmonauts would be cleared for a manual final approach. And that's what they decided to do. On the evening of April 20th, Kurumov once again convened the State Commission. Keldysh, Glushko, Pilyugin, and Vladimir Barman, who had arrived that same day, appeared at the State Commission meeting. It was a great honor for Kurumov to hold a meeting of the State Commission with almost the same personnel as the one that Konstantin Rudnev had convened in April 1961 for Gagarin's historic flight. Once again, it was April, and once again the order of business was to approve launch dates and crew compositions. According to the ballistic specialist calculations, the launch time fell within a window of 3 to 4 a.m. After a brief discussion, a launch date of April 23rd at 0335 hours Moscow time was approved for 7K OK vehicle number 4, Soyuz 1. If there were no serious problems within 24 hours, the launch of 7K OK number 5, which is Soyuz 2, would take place on April 24th at 0310 hours Moscow time. All the chiefs of the state commissions confirmed the readiness of the two launch vehicles and spacecraft. Kirillov reported the test results one more time, but this time he refrained from criticism. On behalf of the Air Force Command, General Kamanin reported on the readiness of the crews and made proposals regarding personnel assignments. Vladimir Komarov was proposed as commander of the active spacecraft, and Valery Bykovsky as commander of the passive one. Gagarin and Nikolaev would remain as backups for the crews. Yeliseyev and Krunov were nominated to be the passive vehicle crew members who would perform the spacewalk and transfer, and their backups were Gorbatko and Kubashov. The State Commission approved Kamanin's proposals without discussion. Keldysh, Mission, Rudenko, Kirimov, and Karas congratulated the cosmonauts and did not forget to wish them a happy landing. Both commanders, Komarov and Bykovsky, gave speeches thanking everyone for their confidence and promising to fulfill the task assigned them. After the State Commission meeting, Chertok asked Chief Designer Mission why Gagarin was named as backup. After all, Smirnov had told him quite recently that Gagarin could fly only with the Politburo's approval. Chief Designer Mission responded, "That's all Air Force monkey business. They convinced Ustinov that Gagarin couldn't be chief of the cosmonaut training unless he flew again." On April 21st, the main operations group departed for the Crimea without Gagarin. Although Gagarin was a member of the main operations control group, he had to remain at the launch site until Komarov lifted off. On April 22nd, training sessions were held, readiness checks of the various services and all the tracking stations, and assignment of people to cover the two spacecrafts in analysis and telemetry groups. Everyone understood that for the first 24 hours, regardless of one's official assignment, everyone would be involved with the first spacecraft, and their duty chart was just a formality. The main control room of the Flight Control Center in Yevpatoria was located on the second floor of a building in the immediate vicinity of the formidable ADU 1000 tracking facility. They would not need the 8 16-meter dishes of this beautiful engineering design to track the Soyuz, because dozens of other individual antennas of various calibers covered the vast area of ground tracking station number 16. Though the individual antennas for the Soviets would receive telemetry information, monitor orbits, transmit commands, conduct telephone communications, and observe the cosmonauts over television, the dozens of antennas were just the visible tip of the radio technology iceberg. Low buildings near each antenna housed the support equipment serviced by hundreds of Soviets, soldiers, and officers. Next, the arrival of generals, state commission members, and members of the brass communing with cosmonauts was a real challenge for the local military authorities. Military service was considerably more peaceful when there was nothing of interest going on in space, and there weren't any state commissions at the tracking station. Vladimir Komarov and Alexei Leonov, the first man to walk in space, had traveled with a group of cosmonauts, engineers, and designers to the launch site earlier. Leonov knew Komarov very well. Komarov was 10 years older than Leonov, but they had worked together on Voskhod. Unlike Leonov, Komarov was always very serious. Leonov considered Komarov to be a first-class test pilot, but everyone, including Komarov, understood that this first manned flight of a Soyuz was a high-risk mission. Soyuz was capable of carrying 3 men, but because of the risk and the flight plan, Komarov would fly alone. The launch days at the firing range in Tyurtam began on April 22nd. Mission Control was in constant contact with the firing range and kept fully informed about the preparation process. On the morning of April 22nd, at the launch pad next to the rocket, a meeting was held of those involved in launch preparation and the launch itself. Feoktistov, Kirillov, officers and sergeants gave speeches reassuring the crews of the spacecraft that everything had been prepared reliably and that the cosmonauts could rely on the technology. Spacecraft commanders Komarov and Bykovsky gave speeches in response. No one, not a single person on the launch pad in Yevpatoria, at the factory, or anywhere else, had any way of knowing what was going to happen, and no pre-flight test could have detected the danger that was hidden in each of the 2 flight-ready spacecraft still at the factory. These first piloted Soyuzes contained a production era that hadn't been present in the previous launches or during all the tests that had been conducted earlier. Up to the day before he was due to fly, Komarov was intently reading all the details for his mission. The night before the launch on April 23rd, Komarov attended a group dinner with the other cosmonauts. There was a tradition at Tyre-Tam of the cosmonauts spending the last night before a launch in the small house that Gagarin did for his 1961 mission. That tradition was broken for this mission. By 1967, a new hotel had been built for cosmonauts at Baikonur, and Komarov stayed there that night. Leonov spent most of that night standing outside the window of Komarov's hotel bedroom. Leonov was determined to direct any traffic away from the street outside so that Komarov could have the best night's sleep possible. The next morning, all the cosmonauts took the bus together to the launch pad. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.